All right, this is summary notes for Chapter 4, Atomic Number, Mass Number, and Isotopes. All right, the periodic table that you have um, looks a little bit like this one square here for an element, although you see all the elements on your periodic table. All right, they're showing the atomic number at the top of the box, and then they're showing you the symbol below. But what if it looked like this? All right, now that looks a little different. All right, and the reason for that is that this is a specific isotope. All right, the mass that's on the periodic table is the average atomic mass, and we'll cover that in a different video towards the end of the summary notes. All right, so when we take a look at a symbol that I've just drawn, all right, I want to point out what the top number represents. And of course, I think you know what the bottom number represents because you can see it over here. All right, so atomic number is the same as the number of protons in the nucleus because the protons give the identity of the element. And that's really important. All right, it gives the identity of the element. What's up here, the 23, is the protons plus neutrons. All right, so you have a nice easy way to calculate how many neutrons are in the nucleus by a simple subtraction. And it's already set up to do that. So 23 minus 11 gives you 12. All right, so there's 12 neutrons in this atom. Okay, so this is something that is specific to an isotope, and sometimes you'll see the name written as sodium 23. All right, because that's the specific mass for this isotope. Whereas on your periodic table it shows 22.99, and it's atomic mass units, or it can also be written in grams. Okay. All right, so here's just a few questions here about filling in the blank to complete the meaning of the symbols. Okay, number of protons. Which one is that one? Okay, I hope you said atomic number. Protons plus what gives you the mass number? All right, and that will be your neutrons, the numbers of neutrons. And then finally, to find neutrons, what did we do over here to find neutrons? All right, we subtracted protons from the mass number. All right, it's that simple. All right, so now there's another one to try, so you can stop the video and try it and then come back and see the answers. Okay, so just pause it and try that, and we'll be coming right back. All right, let's write the symbol for this isotope first, because that always helps you to see how to do the problem. All right, so lead, it's 207. All right, that means its mass number is 207. All right, and I can look up the protons on the periodic table. All right, it's to the right of the transition area. All right, under the staircase. All right, it's element number 82. All right, so if it's element number 82, atomic number 82, it has 82 protons in the nucleus. All right, if we're going to calculate neutrons, we can simply subtract. We don't need our calculator for that. And it's 125 neutrons. The electrons would be the same as the protons because there's no charge over here. Usually when we have an ion, there'll be a charge here. If it's an ion. And we'll learn about ions in the next chapter. Okay. Electrons are the same as protons because it's neutral. All right, so now I wanted to point out to you a very special set of isotopes, and that is for hydrogen. All right, so again, you can put your knowledge to work here and think about what is the same and what is different about these three isotopes. All right, so look at the whole chart. The little circles here represent the nucleuses of the atom, and of course the electrons are on the outside. Okay, so what are some things that are the same? All right, I hope you said proton. because that is the definition of an isotope. Okay, protons are the same number of protons. Okay, what is different? There's several things different, but what makes isotopes special is that they have varying numbers of neutrons. Oops, varying numbers. All right, neutrons. We have hydrogen 1, we have hydrogen 2, and we have hydrogen 3. Okay, hydrogen 1, hydrogen 2, hydrogen 3. But what's even special about these isotopes is that they're the only isotopes that actually have names. Protium for one particle in the nucleus, deuterium for 2, tritium for 3. As protium is a proton and an electron that are attracted to each other. That's all that is. Okay? All right, so here's a set of isotopes here. We have a couple of isotope problems for you to try. All right, you're going to like this one. You're going to want to test on this one. All right, notice the 3 isotopes of carbon here. Carbon 12, carbon 13, carbon 14. All right, you can look on the periodic table to find its atomic number. An atomic number will be, take a quick look. Yes, 6. All right, so 6 protons for each because protons are the same for isotopes. We can do this simple subtraction problem to find the numbers of neutrons. 6 from 12 is 6, 6 from 13 is 7, 6 from 14 is 8. All right, so we have the numbers of neutrons. All right, we mentioned that there's no charge on any of these, so protons and electrons will be the same. Oh my goodness, look at that. Okay, so I hope you can work a problem like that. All right, now here's one that is going to take a little bit more thinking to do, but you can do it. Which pairs of isotopes are the same element? All right, so if you think about what we just talked about. All right, did you say B? All right, why is B the same element? Because it has the same numbers of protons. All right, question number 2 asks, in which of the pairs below do both atoms have 8 neutrons? Remember, neutrons can vary within isotopes, and it's apples and oranges when you take a look at different elements. Okay, so if we take a look at this first set, 8 from 15 is 7. 7 from 15 is 8, so this one's not right. So we already answered this question here for B. 7 from 15 is 8, and 8 from 16 is 8. All right, so this is it. Which pairs below do both atoms have 8 neutrons? All right, they happen to be different elements. They have to be, because your protons, the atomic number is different. All right, so isotopes covered in this video. I hope you understand them a little bit better and can fill out a simple chart like that or answer some questions like we did up here with the lead. Okay? All right, and that's the end of this summary notes video.